Now we are going to discuss about how to create a custom sequence. Again, we'll see more about this, but first let's see the basics of creating a custom sequence. So particularly we'll focus on how to create a custom sequence type that support indexing and slicing, and we'll also see how it support the iterations, right? And then we'll look into the mutable custom sequence in more upcoming lectures. First, understand how this get item method work for iteration and retrieving the elements. Consider that, let me just clear it out. So consider that we have this list. Now, if you want to extract element, right, we can use the bracket symbols, right? So let's say that if we'll say my list and then in the bracket we'll put 0, that will give you the 0th index of the value, right? So it will, like, let's say that here we have this my list and then 0, this will give you the 0th position of the value, which is 0. We can also use a get item method. So this method will also give you the same element. Let's say that we want to extract the 5th element. We'll get 5, right? So here we are accessing the value. Now, but if the index is out of the bound, like we say that, let's say that my list dot get item 6, right? Then we'll get error. We'll get index error, right? Technically, the list object get item method support negative indexing as well, and it also support the slicing. Let's say that when we say that get item -1, this will give you the 5 as a, like this -1 position element, this will give you this element, right? Let's say that when we use a slicing, it also support the slicing. That means we want to slice 0 till 6, but then we want to access 0 and then the, like, instead of 1, now we'll pass 2 and again the 4. So we'll get the 3 element 0, 2, 4. We can also pass this. Let's say that if you in the slicing, if you do not have start and the end value, so we can pass none and then we'll say -1. That means we'll get the all the value in the reverse order, right? Now let's try to mimic the for loop using get item method. So here we have this list having element 1 to 5. Now in the for loop we'll say that for item in my list, and then what we're trying to do is we want to, here we are trying to get the square of each element. So here we're getting 1, 4, 1, 0, 1, 4, 9 and so on, right? Now let's try to do the same thing with the get item method. So here we'll say while true, then we'll try the code. We'll say this try to run this examples like my list dot get item, and then we'll pass the index. We have already set the index as 0. Then we'll say that except index error. This error will happen if we'll reach to the end of the index. Let's say that instead of 5, let's say that here if you'll like here if you'll pass 6, this will give me the index error. So this except will catch the index error and it will break the code. But let's say that if we do not get the index error, so we'll try to print that item like square of each element, and then here we are appending 1 to the index value, right? So here this will give me the 0, 1, 4, 9, 16 and 25. So when it reached the index at 6, here we are past 6 and this we got the index error and then we broke the code, right? So let's implement a custom sequence now. Now we know some basics. Now let's implement the custom sequence. Custom object can support slicing, right? Now here, for that, let's understand that here we are creating class my sequence. Then we are defining a get item method, because we know that get item method will help you to access the element through indexing, and it also support the slicing. So we'll pass self for self object, and then we are passing index over here. And then so here we are just trying to print the type of index and exact index value over here. Let's do this. So first we have to create the object of my sequence. We have created. Now let's try to do my sequence, and then we are past 0. So this 0 will So when we do this, this will call the get item method. So it will call class int because 0 is the integer, and then we are printing the exact index value. Let's pass 100, we'll get that. Let's pass this 0:2, we are passing slice object. So it seems like it also get item also supports slicing. Let's pass this extended slice value. So here we have this 0, 10 and 2. Okay, so it also supports the slicing. We do not have to implement extra code for that. So now in the previous lecture we have seen that the length, like we have seen that given the bound for the sequence, if we give the bound for the sequence and the length of the sequence we are slicing, we can actually define the range functions. We can actually generate the range value. So from the slicing we can generate the actual range object, right? And then we have seen that slice object have the indices method which require a length of the index value, or like length of the sequence value, that will create you the actual range with the start, end and the step value if it is required, right? Now let's try to recall that thing. Here we have the string, we are trying to check the length is 6. So if we'll say slice 062, so this will give you the slicing of 0 to 6, and then 2 is the step value. When we say ls, this will give you the sliced version of string. We can extract the individual object start, stop and step value. When we say s dot index 6, now when we say s dot index, so here when we access this start, stop and step value, this will give you this object. But when we say s dot index 6, which is the length of this string or the sequence data, this is giving you the same object. So we can use this object, we can use this value and create a range, right? We can say that range of 062, and then here we can get that, right? So now we know how to create a range from the indices. Now here is an example. So let's try to implement a Fibonacci sequence type, right? So here let's first implement the get item method. So here in the class Fibonacci we are saying get item, we are passing the s, which is the index here. So here we are passing the f, like first we create the object of Fibonacci, we pass f of 2, we pass the slicing, we'll get the object, right? Now we'll implement both indexing and slicing for our custom Fibonacci sequence type. So basically we'll use this indexing and slicing to calculate our Fibonacci sequence type, right? Now here is the examples. So first we'll try to check that whether this given object is slice or the integer, right? So first in the init method, first we pass the element, right? So first we pass the how many number of, like which Fibonacci number you want to create, right? So here we are passing that, and then we are storing that in this attribute, right? Now we pass this. So first we create this to get how many number of Fibonacci element you want to store, and then in the get item we can pass this s. This would be the, so first we check that this whether this object is slicing or like slice object or the integer object. For that we can use the isInstance functions. We are passing that if s is the like if s is integer, right? So we'll print something, else if it is not integer then it will be slice object. So here we are printing start, stop and the step value. Let's do this. So first we have to create the Fibonacci of 10. So first we will create the object of Fibonacci of 10. This we are done, and then we can extract the Fibonacci of each element. We can say the Fibonacci of 3. So here we are getting, so since we have not implemented it because we have passed this integer object, we have got this. Let's say that here we have passed the slice object, here we are getting this. So we are getting in this form. Now let's add the equivalent range for this. So here again like the code is same, but here after printing it we can extract the exact range value. So here we are saying that s dot index, right? And then we already know that what is the sequence value we want to create. Here we have passed that Fibonacci of 10, so we are passing this 10 over here, and then we'll get this all the IDs. Now we'll use that ID to create range, and now and here we are printing the range value, this exit index value. Let's do this. So first we have sliced this. So here we have sliced here also and here also, right? Here we can see that. So we have now range, right? An exit value inside that range. We have the range of 3 to 5. So we have got this 3 and 4. Here we have passed this call none none minus 1. This means that, so here it will automatically hold this 9, then minus 1, and then minus 1. So this range would be 9 to 0, right? Now we'll actually calculate the nth Fibonacci number. For that we'll use the memoizations, right, which is this technique. Now to use this memoization, so what is this memoization? This means that we want to store the value in a cache, right? So in a temporary cache we are saying, or a temporary I'll say that a memory, right? So for that we'll use this func tools. We are importing this LRU underscore cache to store this or like to store the any element for the temporary basis. Let's import this, and now we can use this as a decorator. We have already discussed what the decorator is and how it works. We are using this as a decorator. Now we are passing that we want to store here. You need to give the range. So we want to store at 2 raised to 10. So whatever the value is, right? So here we are passing this cache, and now we are defining this Fibonacci number. So we are passing n. So n is less than 2. We are returning 1, and then we'll return, and then r. So this is like the technique we are using for the to calculate the Fibonacci number, right? So now let's say that we are saying Fibonacci of 0, Fibonacci of 1, Fibonacci of 2, and the Fibonacci of 50. We can calculate this, right? So all these value will be stored on a temporary basis, right? Now let's use our class method to implement the same thing using Fibonacci, right? And now this is the init method. Now we have the get item method, and now we have implemented this as a static method. We have implemented to calculate the Fibonacci of any number as a static method, right? So let's run this again. We have understood these part already, and this part as well, right? Now the next step is to implement the get item method. We have not implemented the get item method, so let's start by implementing the simple one, which is the simple indexing. So here after in the init method, now if the s value is the integer, that means let's say that if I'm saying that I want to get the Fibonacci of 10, that's the integer, so this will be true, and then it will create the Fibonacci of 10 object, right? Else if this is a slice, so here we are not implementing this, we are just implementing this part. So let's run this. Now let us this. So first we are saying that f equal to Fibonacci of 100. So whenever we'll pass the n, this n will also go over here, right? So it will use the same object. To calculate this function and store the functions, right? It will use this n, like it will do the 100, and it will store the Fibonacci of all the element till 100 and store in a cache memory, right? So if I'll run this, it has calculated the Fibonacci number till 100, and now we can access each element. Here we can access each element. We are saying that f of 0, this means that it will go to this, and then it will run this value, it will run this functions, and then extract the Fibonacci of 0 from this cache memory. So it is not every time it will calculate the, like we are not running this Fibonacci function every time. We are like, when we say f of 0, it will extract directly the calculated value. When I'm saying f of 1, it will extract directly from the calculated memory, like from the stored memory, right? When we do so, it's a lot faster, right? But we still have few problems. Here we are not handling the negative value. So let's do this. So if I'm saying f of 200, and if I'm saying f of minus 5, so for minus 5 we are getting 1, but for 200 we have already calculated the value. So we should raise index error in this kind of situations. So here let's implement this. We are saying that if s is less than 0, that means here we had the minus 5 which is less than 0. So it will be, so it's like we have to calculate, like, so it's like we have to get the, like if we'll do so, we have to get the f of the last fifth value, right? This would give me the f of last fifth value, right? And we are implementing this. So we are adding this negative value to the original value, to the original n value. So that will be our s. And then we are also checking that this value over here. So if it is out of range, so we'll get the index error, and then we'll return that value. So this is how we have implemented, right? Now let's try to run this. So here we are, first we are calculating the Fibonacci of 10. This will calculate the Fibonacci of 0, 1, 2 till 10, and it will store the value. Now if I'm saying f of 9, this will give me the Fibonacci of 9 number. If I'm saying f of minus 1, this will also give me the Fibonacci of 9 number, right? Because 9 is, because minus 1 is same as the last value. So here 9 is the last value, right? We can see that. So the both value in the both term we are getting 55, right? So now the implementation is correct, right? So now it's like we are accessing the stored value, right, from the beginning and from the end, from the, like from the both end, from left and the from right both. We can say f of 10, this will give me error because of these conditions, right? So we have to calculate always till like if we'll say the, like let's say that if I'm calculating f of 10, so this condition will not satisfy, so this will give me the error. You should always extract till 9 according to this conditions. If I'll do so, we'll get index error. If I'll do minus 100, so here this will occur, right? Again, first we'll try this. If this is not working, so it will try this, and then we'll get the error. Here minus 100 will also give me the error because the 10 was the actual value, right? We can also, because this f is the iterable object, because we have created it, so we can also take this in a loop and print every value. So we have calculated each, here we are printing each value, but we still do not support the slicing. If I'll say 0 to 2, we are not calculating the actual Fibonacci numbers. So let's implement this. We have already implemented this part. Now let's implement this part. If we'll get the slicing, so first we'll create the index, then we'll create the range, and then we'll loop over the range and try to calculate the Fibonacci and try to extract the Fibonacci of each value inside the range. And that's it. It's done. So now let's try to run this. First we do the Fibonacci of 10. Let's try to extract the between 0 to 5. What is the value of Fibonacci between 0 to 5? We'll get this. It also supports the negative indexing, right? We can convert this entire f, or entire this f object, which is the iterable, to a list. We'll get all the value. We can also reverse this. So now we have created a custom sequence object, right? But let's try to do this. If we'll do this and let's try to calculate the total length, we'll get error because we have not implemented it, right? So let's implement the length object. So here we have implemented the length object. This will give me the actual n value that we have passed. right? So let's run this. When we calculate this and when we do len of f, this will give me the actual 10 value. So the total length is 10. And yeah, this is it. This is the more advanced, right? We have used this class based approach to implement a custom sequence. We'll see more on this. Thank you very much.